Welcome. In this tutorial we are going to learn about MemoryView. It creates view on internal data of an object without copying it. So with MemoryView we can view the same internal data in different ways without even creating copy of a original object. And if object is mutable and MemoryView is updatable, we can update same object using different views. And for that, object must support buffer protocol. So we know built-in objects such as bytes and byte array supports buffer protocol, so we can create memory view on top of those objects. And for built-in object dictionary, it supports three views: keys, values, and items. So whenever we are invoking those items, the keys, values, and items are not stored separately in different object. They are creating a view object on top of same data structure stored inside the dictionary object. So it will return view object on same singly stored internal data. And for memory view, element is an atomic memory unit which is handled by the original object. So let's begin with the constructor of memory view. So it takes only one argument, which is an object for which memory view is to be created. It creates and returns the memory view, which is reference to the given object obj. So let's create a memory view for bytes object. We have created the memory view for byte object, and if we print it, it will print the object instead of returning the original object. So we need to either collect the elements of the view object into the container, or we can iterate over the element of a returned memory view. So if we collect into any container, so it returns ordinal value for each of the characters. And if we iterate over it, we can also iterate over each element of a given bytes object, and if we print it, it will print each character of given view. We can also index and slice the memory view, same as we saw for the list and tuple object and string object. So we have created memory view, and same memory view is indexed. So it will return the ordinal value for character at given index. And if we slice it, it will return a memory view for that given slice. And if we collect it into any container, it will return the elements of a given memory view. We can also create memory view of an array. So here we have created an array which is containing 10 integer 1 to 10, and we are creating memory view on top of it. So same memory view we can use indexing and slicing to access the data. So this is the first element, and this is the last element, and this is the slice which is collected to the list. Now if the object is mutable and memory view allows writing the data, we can write the data using memory view. So for that, first we need to check whether the view is updatable or not. So for that, read-only attribute is used. So if it will return true if the view is read-only. So we know byte is an immutable object, so it will not allow to write on that particular object, but byte array is mutable. So when we create memory view on top of byte array, it also allows update through byte array memory view. So if we access read-only attribute for both data type and their memory view, here we can see it is read-only for bytes and it is updatable for byte array. So we can use the byte array memory view to update the same byte array object. So let's update. So here we are replacing the slice of byte array with given bytes object. So as we can see here, the same byte object is modified using view object. Now let's see the functions of memory view. First one is tolist, which will collect the data in buffer as list of elements. So we have a memory view of an array which is holding 1 to 10 integers. If we collect to the list, it will return list of all the elements. Next is to read-only, which returns the read-only version of memory view on writable object. So we saw for byte array, by default the created memory view is writable, but we don't want to share a writable view to any method or to the any other object. So we can execute to read-only method on the view, which will return another view which is read-only. So here if we print read-only on the created view object on top of byte array, it will return false. But after creating a new read-only view by executing two read-only method, if we access read-only attribute of newly created memory view, it will return true. As we can see here, it is returned true for read-only on the view returned by read-only. Next method is tobytes. It returns data in buffer as a byte string. It is same as collecting elements in bytes constructor, and it takes an optional argument order which can contain any value from C, F and A. So if it is C or F, the data of original array is converted into the C or Fortran order. And if it is given as A for contiguous memory view, it returns the exact copy of a physical memory. So here the memory view is created, and if we execute tobytes and collect it using the bytes, it will be the same. So same object is written for both of the method, but it will create difference when the order is provided. Next method is hex. It returns the string object containing 2 hexadecimal digits for each byte in the buffer. It takes two optional arguments. First one is a separator. If it is given, it uses given separator to separate each byte. And second one is a bytes per separator. We can group the number of bytes per separator using the second argument. So here for first, we are just extracting hex value for each bytes. In the second execution, we are separating each bytes using colon, and in the last call we are grouping 2 bytes separated per colon. So let's execute it. As we can see, this is the default output of hex method. This is for separator, which uses the given separator for each byte, and for this grouping 2 bytes per given separator. Next method is release. It releases the underlying buffer exposed by the memory view, and it can be customized to take special action such as freeing the dangling resources. For example, for byte array, it temporarily forbids the resizing. So if we try to access the memory view created earlier after execution of release, it will give you a value error. So here we have created memory view and release it. So after releasing, it does not affect the original object. But if we try to access the same view after releasing it, it will raise value error saying that operation is forbidden on released memory view object. And memory view also supports context management protocol. So we can use it with the with statement. So it will automatically release the created memory view when the given code block is exited. So here at this point, it will release the memory view automatically. So if we execute it, it will print the same slice of given memory view, and when it is executed, it will release the view which is created. Next method is cast, which casts the memory view to a new format or shape and returns the new memory view, but underlying buffer is not copied. So with the cast method, we can view the same data which is stored internally in a different manner without creating new objects. So it takes two arguments. First one is a format, is a destination format that can be one of 3 characters, capital B for signed character, B for unsigned character, or the character. And shape is equal to bytes length divided by new item size. So result view is the one dimension. So here we will create a memory view on byte array, and if we try to overwrite any single character using byte object, it will give you an error that invalid type of format is given. So here we are creating another view using cast method, and here we are providing the format. Format is C, means character. So we can replace single element using given byte object. So if we execute same, it will replace the given character at particular index because we have given the format. Now let's cast the single dimensional array into the 2-dimensional or the 3-dimensional. So here we are creating 1 to 12 integer and packing into the struct object, and we are creating memory view on top of that struct object. So we can cast that particular 1-dimensional flat list of or flat sequence of integer into the dimensional we want to view. So here we are creating 2-dimensional view of flat sequence of integer which contains 3 lists, and each list contains 4 elements. So here we are defined the 2 dimension for the given flat sequence. So if we execute it, the result sequence look like this. So it will create first the 3 list, and each list contains 4 elements. So that number must match with the number of element which is packed inside the sequence. So it contains 12 objects. If we divide it, so 3 lists and each list containing equal number of 4 elements. So it is organized using this structure. Same way we can define 3-dimensional object like this. So for first dimension it contains 2 lists, and that 2 list contains 2 lists inside. Inside those 2 lists there are 3 elements. So if we create it with the shape 3-dimensional, and if we check it to list, here we can see it is creating 3-dimensional view on same sequence of flat integer sequence. So here first the 2 lists inside the list for first dimension. For second dimension there are 2 lists inside the outer list. So here 1 and 2, 1 and 2, and for each inner list there are 3 elements. So if we total it out, 3 into 2 into 2, it equal to 12, which is a length of a given sequence. So that must match for each of the given shape here. So same way we can create the different view for the different sequences. So here we are just changing the size of last container and second dimension. So here it is containing 2 lists for outer. Inside the 2 list it is containing 3 lists, and each list containing 2 elements. Next is attributes of MemoryView. First one is obj. It will return the same underlying object of a MemoryView. If we execute it, it will return same byte array object because we created MemoryView on top of byte array object. Next is nbytes. Returns the amount of space in bytes that an array would use in contiguous representation. For n byte it is not necessary, it is equal to the length of the object. So this is the first case when the length of object is equal to n bytes. So here we are storing 5 integer 1 to 5, and if we execute len and n byte, it will return same for byte. But if we are storing inside the array same element 1 to 5 and we are creating MemoryView on top of it, and if we take len and n byte, it will not be the same. So here it contains 5 elements because now the elements are represented using integer, not bytes. So bytes is 20. Next attribute is readonly. So as explained earlier, it will return true if the given view is read-only. So for byte we know it is immutable object, so it is read-only, and from byte array it returns the updatable memory view, so it will return false for it. Next is format. It returns the format of an underlying object. So here we are storing it inside the struct object and we are creating memory on top of it, and if we execute format, it will return the format which is used to store or exposed as a memory view. So earlier we saw the 3 symbols, it is same. Next is item size. It returns the size in byte of each element of a given memory view. So here we are creating an array of long from 1 to 5, and if we check item size, it will store 8 bytes for each element of a given array. Next is shape. It returns the tuple of integer representing the shape of memory for given n dimension of array. So earlier we saw we can define shape using cast method. So same shape can be accessed using shape attribute. And strides return the tuple object of integers, the length of ndim giving the size in bytes of each for each dimension of array. So we will see with the example here. And ndim returns the dimension or the length. So based on the ndim dimension, we can know the length of the view. So for 0 element, it will return 1. So for 1 dimensional, it will be equal to the number of elements inside the view, and for greater than 1 dimensional, it will contain length will be equal to the nested list represented of a given view. So let's see it with example. So here we are creating memory view on same 12 integer, but we are storing in the different view. So this is a 2D view and 3D view, and we are accessing the same attributes, and we will see the output. So here it is stored in a two-dimensional. So ndim will return 2 because it is a two-dimensional view. For length it will return 3 because inside the list there are 3 elements, and for shape it is returning the shape we are provided inside the cast. For strides it will return, this is a number of bytes which is used to represent single element of memory view, and this integer is representing each single element inside the memory view. So it contains 3 elements and each element is of 16 bytes because it's storing 4 elements. So 4 into 4 equal to 16. And for contiguous it will return true if it is stored in a contiguous memory. Same we execute for 3-dimension view. So as we can see here, ndim will return 3. Length is 2 because inside the outer list there are only 2 elements. Shape is original shape. For strides, each individual element is stored using 4 bytes because it's an integer struct. And for second dimension it is returning 12 because each inner list is having 3 elements. And for outer list it is holding 6 elements, so it is returning 24, and it is stored in a contiguous memory, so it is returning true. Now we can also access elements of n-dimensional view using indexes. So we can provide a tuple object containing indexes in the given dimension. So here we have created 3-dimensional view, so we can provide 3 indexes representing indexes in 3 dimension to access a particular element. So here if we execute it, so this is a 3-dimensional view toolist, and if we try to access it using 0, which means first inner list inside it, this is the list which is selected by index 1, and second element which is 5. And for same, this is the second list is selected first, 0th index which means this list, and second element which is this 8. Same way we can use it for any dimension using this tuple object. And if it is a 0-dimensional memory view, we can index it using empty tuple object. Next is C contiguous and F contiguous. So for C contiguous it returns true if the memory is C contiguous, and for F contiguous it will return true if the memory is Fortran contiguous. So we have created buffer on struct object containing 12 integer elements. If we execute it, it will return true or false based on the given memory view, and if it is contiguous on defined C or Fortran, it will return